Hello viewers, I am Deepti Hans. My topic for today is moment of a force. As we know, when force is applied on a rigid body, there will be two types of motion. If the body is free to move in any direction, then if we apply force, then it will move in the linear, or you may say translational or rectilinear motion. If the body is free to move, then it moves in a linear motion. But what happens if the body is pivoted at a point? Suppose it is fixed at a point. When the body is fixed at a point and we apply force at a convenient point, then you may see that the body starts rotating. And this is known as rotational motion. Rotational motion, or the turning effect of the force, you may also say. For example, if a wheel is pivoted at its center, or you can say axle, and we apply a force on its rim, then the wheel starts rotating. This is known as rotational motion. Anti-clockwise motion or clockwise motion, it depends on the direction in which we are applying the force. Turning effect on the body about an axis is due to the moment of force. Moment of force depends on two factors: the magnitude of force which apply. More the magnitude of force, more is the moment of the force applied by you. And second is the perpendicular distance of line of action from this axis of rotation. This is the perpendicular distance of line of action from this axis of rotation. Larger the distance, more is the moment of the force applied by you. So moment of force is the product of force applied, magnitude of force applied, and the perpendicular distance of line of action from the axis of rotation. Conventionally, if the effect on the body is such that it starts moving in the anti-clockwise direction, then this is taken as positive. And if it is in the clockwise direction, then it is taken as negative. Now, how can we change the direction of rotation of a body? There are two ways. One is by changing the point of application of force. If I am applying a force such that the body starts rotating in this direction, then this is known as clockwise direction. Or if I start rotating I change the point of application of force and body start rotating in opposite direction, then this is anti-clockwise direction. Or by changing the direction of force applied on the body. If I apply force in this direction, then this is clockwise. If apply force in this direction, then this is anti-clockwise. So these are the two ways in which direction of rotation of a body can be changed. Now we will talk about a few examples of moment of force. First of all, as we might have observed that to open or close a door, we need a handle which is provided at the farthest distance, at the maximum distance from the axis of rotation. As we all know, axis of rotation is where the hinges are provided to open or shut the door. If we try to open this door and handle is provided at the middle point, suppose Q, then we need a larger force to open the same door. And if we apply handle at this end near the hinge and we try to open the door, it may be impossible for us. But if the distance is maximum and we try to open this door at the maximum distance from the hinge, it means the perpendicular distance of line of action from the axis of rotation. Perpendicular distance of line of action from the axis of rotation is maximum, and this provides a minimum force to do the same job. We might have observed a hand floor grinder. In that hand floor grinder or dadima ki aata ki chakki, we have provided a handle near its rim. Rim is the outer portion of a circular body which is at the outermost region. So this is the rim. Handle is provided near its rim so that we can rotate the hand floor grinder with the help of our hand very easily, because the axis of rotation is at farthest distance, so that less force will make this hand floor grinder to move easily. Now next is the example of a spanner. A spanner is used to tighten or loosen a nut. It is provided with a long handle so that by applying a less force near the end of this handle, we can give a large moment of force, because we know the larger the distance, perpendicular distance of line of action from this axis of rotation, the lesser is the force needed to do the same moment of force. If we want to loosen a nut, then we have to apply the force in the anti-clockwise direction. And if we want to tighten a nut, then we have to apply the force in the clockwise direction. Similarly, a jack screw is used to lift a heavy load such as a vehicle. It has a long arm so that it can be rotated easily. With a less force, we can easily raise or lower the jack. Conclusion of all these examples is the turning effect of a body depend on two factors. One is force and another is perpendicular distance of line of action from the axis of rotation. Larger the perpendicular distance, lesser is the force required to turn the body. Actually, rotation is always produced by a pair of forces. A single force cannot rotate a body. We apply force externally and in reaction it has a force at the pivoted point. But the distance of this point from the line of action is 0. So we are not considering this force. But in reality this externally applied force and reaction force form a couple. So two equal and opposite parallel forces not acting along the same line form a couple. Couple is always needed to rotate a body. Sometimes we require a large turning effect. Then two forces which are equal in magnitude but opposite in direction are applied on the body such that they both rotate the body in the same direction. As you have seen, while turning a water tap, we applying these equal and opposite parallel forces to open or close the tap. Similarly, you have seen in the water bottle, while opening or closing the cap of the bottle, you apply this couple of force. So always when we need rotation, we need a pair of forces which is known as couple, which are equal in magnitude but opposite in direction. Hope you have understood moment of force with the help of these examples. If you like my video, please do share, give your valuable feedback and subscribe to my channel. My next video will be on principle of moment and its numericals. Thank you.